Hi, this course is on data structures using C and C++. Learning data structure involves understanding the concepts thoroughly and analyzing data structures and operations on data structures, as well as implementing data structure using some programming language. So I have focused on all these three things. I have discussed the concepts in very much details that are easy to grasp and remember. Every data structure and the operation upon data structure, I have analyzed it thoroughly based on time and space complexities. And I have implemented the data structures using basically C language. Then afterwards, even I have shown how to implement them using C++. So for taking this course, you must have prior knowledge of C programming, and little bit of C++ like classes and objects is sufficient. And even if you don't have the knowledge of C++, you can complete the course thoroughly because I have mainly used C language. Now, who should take this course? All those who want to understand data structures, concepts thoroughly and use those data structures efficiently in application development, they can take up this course. Like academic students, as a part of their syllabus, they can learn data structures and practice data structures. And if you are a programmer, you have been developing applications, now you want to have good understanding of data structures, this course will definitely increase your knowledge and analytical skills so that you can efficiently utilize data structures in application development. And also, if you are going to face a job interview, then the clear-cut concepts of data structures will definitely give you a lot of confidence for taking up any coding challenge and clearing your job interview. The course is around 45 hours. Each and every concept is discussed on whiteboard, and also code is written line by line by explaining each and every line on whiteboard. And also I have given practical demonstrations using C language as well as C++. You can go through the contents of the course. I have given some preview videos. You can watch them and you can take up the course. Definitely this course is going to help you and you will enjoy learning data structures with me. Hi, welcome to my course. I'll guide you how to follow this course. This course is covering around 45 hours. Then it means you have to spend some extra time for learning this course. So I suggest you to complete this course in a timely manner. So you spend at least 2 hours per day so that you can finish it within a month. Then while studying, you can watch whiteboard session, and whatever is discussed in whiteboard session, you can prepare notes if you want. And every program is discussed on whiteboard. So you can pause the video, or at the end of the video, you can start coding the program by yourself. So everything is discussed on whiteboard, so you can do it by yourself. If at all you face any difficulty, then you can watch a coding video. Coding videos are also available, and along with the coding video, a PDF of a program is also available. You can verify your program with that PDF content. And the most important thing is analysis. There is a video on time and the space complexity in the beginning of the course, so you must watch that video. I have done analysis on each and every data structure and operations on the data structure. Now, while watching a video on analysis, I suggest you practice it by yourself. And if you are doing the analysis by yourself once, that will help you remembering the analysis and applying them in the right place. And one more thing, asymptotic notations are used for representing the time complexities like big O, omega and theta. These are simple terms, these are nothing. Without that also you can represent the time complexity. These terms mostly confuse the students. So even I have covered about asymptotic notations. You can watch the video available for asymptotic notations. I have discussed when to use big O, omega and theta. But during my discussions, I have not used these notations to make topics simple and easy for you to understand. At any place, if you find any difficulty, you can leave a message to me. You can go to question and answer section, and there you can leave a message. And if you have any trouble in coding, you can send me a screenshot so that I can quickly reply you. So I am there with you always. Whenever you face any difficulty, you can put a question in a question answer section. And that's all. You can start learning data structure course. You will enjoy the course. Let us start with the introduction to data structures. Data is an integral part of our applications or programs. If I define a program is nothing but a set of instructions which perform operations on data to get some results. So without data, there is no need of instruction, no use of instructions. Then the data term data, we use it at many places like data structures, databases, data warehouse, big data. So from this, what is actually data structure? So for this, if we have the little bit knowledge about all other things also, that will be better. So first I'll start with data structures, and we'll also have the brief introduction to databases and data warehouse as well as big data. So first let us start with introduction to data structures. First of all, let me introduce what is data structure. Data structure can be defined as arrangement of collection of data items so that they can be utilized efficiently. Operations on that data can be done efficiently. So it's all about the arrangement of data and the operations on the data, that are efficient operations on the data. But the question is where? Inside the main memory during the execution of a program. So without data structure, there cannot be any application. Every application will have set of instructions which will perform operations on data. So data is mandatory. Then where the data is kept? Inside the main memory. Where the programs will be? Inside the main memory. Right? So during the execution of a program, how the program will manage data inside the main memory and perform the operations, that is data structure. So I'll take an example and explain you in detail how the program utilizes data and how they put the data inside the main memory. Let us look at this diagram. Here is the CPU processor, that is central processing unit, that is our microprocessor, and this is main memory. Let us say this is RAM, and this is a storage, that is hard disk drive or external storage, or just we call it as storage. This will execute our programs, that is, it is a processor, it will execute the instructions. And this is temporary memory, that is working memory. It is also called as primary memory. And this is permanent storage. This is permanent storage. So if we look into our PC, then we will have a processor, RAM and hard disk. Or if we look into a mobile phone, then there will be a processor and there will be some RAM like 2 GB or 3 GB or 4 GB of RAM, and there is a storage of 16 GB, 32 GB or 128 GB like this. Then where do we keep our programs? When we install any program in our PC or on our mobile phone, a program or an application will get installed on storage. So here I am showing it as a program file. This is a program file. Then where do we keep our data? That also we keep it on hard disk. Suppose you have any pics or photos or videos or any documents, that all you keep it in your hard disk, or in your mobile phone you keep it in a storage. So these are data files. So I'll take one example of a commonly used application like MS Word. Most Windows users use MS Word, commonly used software, or Notepad also you can take. Assume that this is MS Word program file and this is document file or docx file, and this is MS Word file. Now through this example, I'll explain you where the data structure comes into picture and how MS Word may need data structure. Now let us see how our application program runs. If you want to run MS Word on your PC or your mobile phone, you are touching an icon or double clicking an icon of MS Word, then let us see what all happens. This MS Word program will be brought into the main memory. So it is brought into the main memory. So let us say these are all the instructions of MS Word program, such as I am showing lines to show the machine language code or instructions of MS Word program. So whenever you want to run an application, the application code or the program code has to be brought into the main memory. Then once it is brought in, CPU will start executing this MS Word application. So you will see a window appearing on the screen, and then all the menu options, everything comes up and you can start using MS Word. Now, if you want to open a file, document file in your MS Word application, Suppose this program wants to access this data in this file, then this data also has to be brought into the main memory. So let us say this is data, or this is some Word document file. So data is also brought into the main memory. Now from this I can explain that, I can say that a program has to be brought into the main memory for its execution, as well as data has to be brought into the main memory for processing on the data, so that these instructions can perform operation on the data. Program cannot directly process the data keeping it on the storage. The data has to be brought into the main memory. Now from this we can say that every application deals with some data, whether it is MS Word, or if it is Notepad, then the Notepad file, text file has to be brought into the main memory. If it is a Chrome, you are browsing any web page, then that web page, when it is coming from internet, it has to be in the main memory. So every application on your computer system or your mobile phone deals with some data, and that data has to be inside main memory. How you organize the data inside the main memory such that it can be easily used by this application, efficiently utilized by this application program. So how you organize the data? So the arrangement or organizing of the data inside the main memory for efficient utilization by the application, that arrangement is called as data structure. So data structures are formed in the main memory during the execution time of a program. When the program runs, it needs data. So the question, how it will arrange the data in the main memory for performing its operations. So that arrangement is called as data structures. So data structure is a part of running program. You may be knowing different data structures like arrays or linked lists or trees or hash table. Whatever the data structure is suitable, an application can use that particular data structure here for arranging its data. Data may be a text data or multimedia data like images or videos. A lot of contents may be there in the form of data. So all those contents, how they are organized in the main memory. So we have to design some data structure so that the application can use it perfectly or more efficiently. An application should work faster or process faster over that data. So that's it. So I have given you the idea what is data structure and where it will be in your computer system. So it is not on the disk, it is inside the main memory. So without data structure, we cannot develop any application. Now let me give you some idea about databases. See, when the data is larger in size, or commercial data that is used in businesses like banks or retail stores or manufacturing firms, they will have a lot of data and they will have some organized data in the form of database tables or relational data. And where they keep that relational data, all that data is stored on the disk. So I'll just remove this and show you a relational table that is kept on the disk. Now you can see here that on the disk, on the hard disk, this is a table, database table. I am showing only one table. There may be many tables. Data may be spread across various database tables and it is organized in the form of tables, and the tables are having relationship between them. So mostly commercial data is stored in the form of database tables. Now, if any application program is using that database, then data has to be brought into the main memory, then only it can use it. So again, you need data structure here. When you are pulling the data from the hard disk or from the storage to the main memory during execution, then you need definitely data structure here. So arrangement of data here in the main memory is data structure. Then how this data is organized in the form of table on the disk, this is database. This is database. Just brief introduction I am giving you. Database means arranging the data in some model, like say relational model, in the permanent storage so that it can be retrieved or accessed by applications easily. That arrangement in the hard disk or in the permanent storage is called as database. Then next, let us go to the next term. Like I was talking about commercial data, that is data used in businesses. So they will have huge amount of data daily coming in, like many customers are making transactions or lot of goods are manufactured and sold. So the data size will be growing day by day, large and large. So large size data are very large data that may not be used daily, right? Like 1 year old data or 10-year old data that may not be used now. So commercial data can be categorized into two, that is operational data or legacy data, old data. Operational data that is used, that is daily, and legacy data can be kept as storage somewhere. If required, we can fetch that data and use it. Or you can say historical data. So that historical data can be kept on array of disk, because just imagine 10 years of data or 50 years of data is kept on not just one disk, array of disk. So the large size data which is kept here, that is acting as a historical data for any commercial firm. This is data warehouse. This is data warehouse. So mostly commercial firms will have their data warehouses. That data warehouse is helpful for analyzing the business or making the policies or starting a new trend or giving offers to the customers, dealing with the customers. So that previous data, old data, will help organization in taking decisions. So this large size data is data warehouse, and the algorithms written for analyzing that data are data mining algorithms. Data mining algorithms. All right. So wherever data is used, I'm explaining about that. See, this is database, right? Database. This is data structure. So data structure inside the main memory during the execution. Database on the disk, large size data, and the huge size data which is inactive now, and when required it is utilized, that is data warehouse. And the last term, that is big data, is the term used nowadays. Big data. With the start of internet, a huge size data is accumulating day by day in internet. That data is about things, about people, about places. A lot of data is available in internet, and by analyzing that data we can take a lot of decisions, that is for management, for governance, or for businesses. Analysis is very useful about that data. Storing and utilizing that very large size data, that study is big data. That study is big data. Now, for a beginner, these are maybe confusing terms, so I have separately defined them where each is used. Again, I repeat, data structure is in main memory during the execution of a program. Arrangement of data here. And arrangement of data on the disk is database. Arrangement of data in the array of disk as data warehouse. That is not operational, that is not used day to day. And big data, that is used in internet. So that's all. I have given you the different places where data is used. Now our subject is data structures. So let us start with data structures in next video onwards. In the previous videos already we have studied how a program utilizes the main memory by dividing the memory into sections like a stack and heap. And we have also understood what is static memory allocation and what is dynamic memory allocation. Now let us move to the topic, that is introduction of data structures. In this video, I'll be giving introduction to various data structures. I have categorized them here as physical data structures and logical data structures. So first I'll explain what are physical data structures, just the introduction, then introduction to various logical data structures. Now let us look at physical data structures. These are the two physical data structures, array and linked list. We can have more physical data structure by taking the combination of these, that is array and linked list. We can have some variations in them. Basically these are two. The first thing, why I am calling them as physical? The reason is these data structure decides or defines how the memory is organized, how the memory is allocated. So let us look at them one by one. This is an array. This is directly supported by programming languages, like it is there in C language and C++, and even in Java, this is directly supported. This is a collection of contiguous memory locations. All these locations are side by side. If I have an array for 7 integers, then all these places for 7 integers are together. They are at one place. This array will have fixed size. Once it is created of some size, then that size cannot be increased or decreased. So it is of fixed size. So the size of an array is static. Where this array can be created? An array can be created either inside stack or it can be created inside heap. We can have a pointer pointing to this array. So array can be created either inside stack or inside heap. Anywhere it can be created. When to use this data structure? When you are sure what is the maximum number of elements that you are going to store. If you know the length of the list, then you can go for array. Now, second data structure, linked list. This is a complete dynamic data structure, and it is a collection of nodes where each node contains data and linked to next node. The length of this list can grow and reduce dynamically. So it is having variable length. So as per your requirement, you can go on adding more and more nodes and add more elements, or you can reduce the size. This linked list is always created in a heap. Collection of nodes are created always in a heap. Like head may be a pointer that is pointing there, so the head pointer may be inside the stack. So linked list is always created in heap. We go with this one if you know the limit of list or the size of the list if it is fixed. And we go with this if the size of the list is not known. So these two are physical because they define how the memory should be organized for storing the elements or for storing the data. So these are more related to memory. So I have just introduced these two data structures to you as this is a separate topic in our subject. Now let us move on to the next type of data structures, that is logical data structures. Now let us look at logical data structures. See, here are the list of logical data structures that are stack, queues, trees, graphs and hash table, and these are physical data structure already we have seen. Now let us look at the differences between them. Physical data structures are actually meant for storing the data. They will hold the data, they will actually store the data in the memory. Then when you have the list of values, you may be performing operations like inserting more values or deleting existing values or searching for the values and many more operations. Now the question is how you want to utilize those values. How you will be performing insertion and deletion. What is the discipline that you are going to follow? That discipline is defined by these data structures. That is stack, queues, trees, graphs and hash table. These are linear data structures and these are non-linear, and this may be linear or tabular data structure. Hash table, so it is a tabular data structure. Stack, this works on discipline that is LIFO, last in first out. Queue works on the discipline that is FIFO, and this is a non-linear data structure. This will be organized like a hierarchy, and this is collection of nodes and the links between the nodes. So these data structures are actually used in applications. These data structures are actually used in algorithms, and for implementing these data structures we either use array or linked list. So this is the important point that we have to learn in this topic. That is, these logical data structures are implemented using any of these physical data structure, either array or linked list or the combination of array and linked list. So that's all. I have given the introduction of various types of data structures. I have categorized them. This was just the introduction to give you awareness. So the conclusion of this topic is I wanted to differentiate type of data structures, that is physical data structures, array and linked list, and these are logical. And these logical data structures are implemented using physical data structures, either using array and linked list. So throughout our course, we will learn about each data structures and we will implement them using array as well as we'll implement them using linked list. So we have to learn this. Here I have given just names of the data structure, some of the data structure. If you pick up each topic, there are a lot of subtopics in them. Like there are different type of queues, there are different type of trees, and there are different type of graphs. So each and everything we learn all those things in detail. So in our course, we will be first learning in detail about this arrays and linked list data structures. We will implement them. We will write the programs for these. Then we'll start learning about these data structure. Every data structure we will implement using array as well as linked list. So in the next video, I'll explain what is ADT and what are the various type of lists.